Hi everyone, my name is Aman and I'm working as a DevOps lead at Velotio Technologies. Today we are going to be talking about observability, and this topic will be covered in three parts, where in first part we'll talk about metrics. So what is observability? Observability is a property of a system. So if your system is observable, what does that mean? It means that you should be able to visualize what is going on inside your system without actually knowing the internals of your system, right? So because of some external metrics or outputs that a system gives, you're able to understand what is going on inside the system and how it is behaving, right? You're able to understand the behavior of the system. That is what observability is. Okay, so we understood what observability is. Now let's understand what are the three basic pillars of observability, right? So three basic pillars are metrics, logs, and tracing, right? So let's start with metrics. What are metrics? Metrics are an important measure of application and system health over a given period of time. For example, memory used by application over a span of like 5 minutes, 2 minutes, anything like that. Second is logs. So logs are nothing but timestamp granular, comprehensive, millisecond by millisecond record of application events. So we have all been through like system logs or application logs. So they all come under logs, right? And the third part is tracing. Tracing is nothing but end-to-end path of every user request, right? Right from your front end to back end to DB and then back. So that's a typical in a three-tier architecture. That is what generally happens. So that is what tracing is. So now we have understood what observability is. We have understood like what are the three basic pillars of it. And now we are talking about metrics, but then how do you get started? Like what should you measure, right? And for different things, what like infrastructure, another part, application, what should you measure? So there are strategies defined for all of these things. So one is called the use method. Use method is utilization, saturation, and errors. So utilization is the percentage time the resource is busy. Saturation is the amount of time, amount of work that a resource has to do. And third is the errors, the rate, the count of errors, right? This use method is basically defined for infrastructure resources like CPU, memory, and network devices, right? So it will not apply to services and applications and things like that. So for that, we have got the RED method, which applies to your microservices environment. So RED method is rate, errors, and duration. Rate is the request per second. Error is the number of requests that are failing, and duration amount of time that each request takes. Now these RED, what we have defined, what should you measure? So these are actually a proxy to your user, right? What your user will experience, like what is the latency that your user experience? What are the errors? How often the errors happen? So you set up your alerts based on this. You generally don't care what is happening to your system. You do not set alerts on that. You set alerts on how your user is behaving, like how the front end is behaving, what is the rate, duration, and errors. So but both of them go hand in hand. It is not that you cannot stop observability on your systems as well, right? So both use and RED go hand in hand, and you set up alerts on the symptoms are what your user experience, and the root cause may be lying with your system that your use method will measure, right? So this is about use and RED method. Let's go further to what are the four golden signals. The four golden signals are similar to RED. So this was prior to when RED was published, and this has been published in the Google SRE handbook. So this talks about latency, which is similar to duration in RED. Traffic is similar to rate in RED. Errors is the errors in RED, in the RED terminology. And saturation is the only thing that is added here, which tells you how full your system is, right? How much of the memory that has been allocated to it is actually being used, right? So that is the saturation part. Okay. So let's go further. So now we have understood like what to measure, but now we come to like how you should measure it. So there are various tools in the market, but Prometheus is the most widely open source tools for measuring metrics, like for collecting metrics and visualizing it on Grafana, right? So typically this is what the architecture looks like. So you have got a Prometheus instance that you set up on each of your Kubernetes clusters, from where it collects metrics from various kind of exporters like Node Exporter, MySQL Exporter, and CA Advisor and things like that. So it collects those metrics. You can set up alerts on those metrics. You can configure this as a data source in Grafana and view your dashboards here, right? And then, but to have a higher retention period and like more availability, you push these metrics to a highly available Prometheus, which is also called federation. So this is what a typical architecture looks like. But there are some challenges around it. So what the challenges are is, first, you don't want to manage. So suppose you have got 15, 20 clusters, you don't want to manage Prometheus storage on all of them, right? Second is cardinality explosion. So if there are too many metrics, so that will blow up your Prometheus memory usage by a lot. So Prometheus basically stores your metrics in a time series database. So, and there are too many time series, it can lead to memory explosion, and that can lead to out of memory errors, and Prometheus might die, right? So, but there are solutions around it. First is, if you don't want to manage storage, you can use things like Grafana agent or AWS Hotel collector, which are nothing but they get your metrics from your exporter and then push using remote write to your central managed Prometheus. So instead of maintaining Prometheus on every cluster, you can directly push it to the central Prometheus. Second is exploring long-term storage solutions like Victoria Metrics, AMP, and Grafana Cloud, etc. So these are the solutions around it that we have. Okay. So what are the things that you should keep in mind before, when you're designing observability and when you're measuring your metrics, right? First is determine the retention period of metrics. So you want it for a month, you want it for 6 months. So all those things that come from business requirements. So you determine it so that your metrics are archived periodically, right? Second is be aware of cardinality of metrics that we have already talked about. That is number of time series in the DB, right? Third is drop unnecessary metrics that are not being used, right? So similar, like there are some metrics that are not being used either in your dashboard, neither in your alerts, then you can go ahead and drop it. Why unnecessarily waste storage on it or system resource on it? And fourth is for long-term storage, evaluate there are different tools in the market, evaluate what best suits your needs. So Thanos, Cortex, AMP, Grafana Cloud, Victoria Metrics, these are all the tools that are available in the market. Okay. So how simple is this? What do I need to do to set this up on my cluster, right? So this is how simple it is. You just need to run a command, fill in the required thing in values file, just need to run a command. So kube state metrics is an operator used to manage Prometheus. So using that, you can install the basic exporters like Node Exporters. Kube state metrics is another exporter. So you can install that using kube Prometheus stack. And you can even install Grafana using kube Prometheus stack, and then you can visualize it like I've done in the screenshot showed below. So where you can see what is the CPU load, what is the RAM used, what is the swap used, and the basic things, right? And these are basically the references. Okay. So in the next series, we are going to cover, we are going to talk about logs. So how do you start with logging? What should you measure? How you should measure? The similar pattern we are going to discuss in the next series. Thank you, guys.